Welcome everyone. Today we're going to discuss about the Open Optical and Packet Transport Project Group. The Open Optical and Packet Transport Project Group is an initiative within the Telecom Infra project that tries to accelerate innovation in IP and optical networks. But let's go to the next slide and we'll discuss about that in a second. I'm going to share with you the agenda for today's session. We are going to start with a quick overview of what we do at OPD, going through our scope and the main topics that we're going to cover in the session today. Then we're going to discuss about physical simulation environment and specifically about the GMPY tool. Then we're going to discuss about one of the newest initiatives and subgroups within OPD called mandatory use cases for SDN transport. And finally, we're going to discuss about other stuff that we are doing around optical networks within the disaggregated optical systems subgroup. If we go to the next slide, we are coming back to the first point that I was making around our objective. Let's go to the next slide. Yeah, this one. So as I was saying at the beginning, our goal is to accelerate innovation in IP and optical networks. I always say that some traffic comes from the mobile access network, and some traffic comes from enterprises, and some traffic comes from fixed access networks. But all the traffic goes through a transport network. So we are helping operators to accelerate innovation in IP and optical domains and providing connectivity for communities around the world. This is our main mission. And for doing that, we work with operators, as I said, and also technology providers that are willing to open up this telco area and build solutions that are more open and more efficient than the traditional ones we have available. If we go to the next slide, we're going to enter into a little bit more details of what we do at OPT. OPT is a set of initiatives and a set of subgroups, the ones that you guys can see here, that try to develop technologies across the entire IP and optical domains that operators can use to optimize the transmission capacity and deliver more capacity to their access networks. Starting from left to right and then bottoms up, the first initiative that we're going to mention here is disaggregated cell site gateways. Disaggregated cell site gateways is an initiative that tries to build open and white box-based aggregation routers for fixed access, mobile, and enterprise type of use cases. DCSG is one of our most successful initiatives, and it has a wide adoption across the industry. We have commercial deployments in 4 continents these days, with operators like Telefonica, Vodafone, and so on leading the way. Disaggregated open routers, it's an initiative that tries to follow the same model that we started with disaggregated cell site gateways, but going into the aggregation and core domains. We all know that obviously developing solutions and aggregation solutions that are that have more capacity and that can provide a higher speed interfaces is even more complex than delivering solutions like cell site gateways. So we started based on the learnings that we obtained from DCSG, and now we're developing solutions like OpenBNG or disaggregated backbone routers that operators can deploy at different parts of the network, collecting the traffic coming from the access and the backhaul. Now, if we go into the next one, disaggregated optical systems, and we'll discuss about that in a second. Disaggregated optical system focuses on the optical layer, on the layer 1, layer 0 stuff. So within that project group, we develop a set of technologies that operators can use to deploy and develop and provide more capacity across their optical infrastructure. Then we'll cover that in a second, but physical simulation environment is one of our main initiatives that is building a GMPY, a very nice and useful tool that operators can use to simulate and optimize the capacity and simulate multi-vendor optical network in real case scenarios. Gert is going to help us in a second explain that even better than I do. Then we recently created a new subgroup called mandatory use cases for SDN transport, mandatory use cases requirements for SDN transport. And that subgroup has just started and it's progressing super fast. And the main idea is to help the industry evolving towards open and disaggregated and standard-based interfaces for all the technologies that we see underneath, IP, optical, and even solutions like wireless backhaul. Then we have other subgroups like CANDI, converged architectures for network disaggregation and integration, where different operators get together and define the new technologies, new use cases, and new architectures that operators will deploy in the future. And finally, we have network operating systems, which develops an open source network operating system that we call OPT NOS that can run on different devices that are being produced in the other subgroups like disaggregated cell-site gateways, DOR, or disaggregated optical systems. Let's go into the next slide, and I'm going to be quite quick here. These are the main three topics that we are going to cover today. We're going to discuss about GMPY and what the community is doing in a physical simulation environment. Then we're going to discuss about mandatory use cases and requirements for SDN transport. And finally, we're going to discuss about what we are doing at disaggregated optical systems in projects like Cassini or Felix. So I'm going to pass the mic to our next speaker, which is Gerd Garmer from Juniper, who is going to tell us more about what the team is doing in a physical simulation environment, PSC, and how GMPY is evolving. Welcome, Gerd. Over to you.
Hi, thanks, Diego. So let's go to the physical simulation environment. It's a kind of awkward name, but let me explain to you a little bit more of what it is really dealing with. Next page, please. So what is the problem? The problem in the optical space, it's a non-standard environment, meaning every optical vendor has its own way of solving problems and its own way of designing their system. And because every vendor has its own way of designing, those designs are typically under NDA. So it's not easy for an operator to say, okay, I like a design from vendor A and they would like to apply it, or I want to use some of the devices from vendor B. That's basically not possible. Also, since the vendors do not expose any kind of limitations, you know that your network works, but you don't know how far it will go. So what is the kind of the stretch that you can still achieve with your network? And that creates a kind of excessive complexity also comparing proprietary offerings. So imagine you have two offers, one is cheap and but works, and the other one is expensive but also works. So you cannot be sure that the expensive one has more reserves, is more resilient, or has, let's say, better optical parameters, unless you really test it yourself. And then it kind of creates really a mental lock and often a kind of over-dimensioning of proprietary closed system. Next page, please. So how are we addressing this in the PSE team? So the key point is to have a trusted performance evaluation that can be shared among operators, integrators, and vendors. So this is actually what operators are already doing. They kind of draft their own network because they know how the network looks like. They simulate it with GNPY, so they have a good understanding of what kind of performance they need. And then they go to their system vendors saying, okay, you can do your own simulation and we can compare what you simulated with what I simulated, and I see where the bottleneck is. So this allows a collaborative optical network design. So it's basically a one-to-one communication between the operator and the system provider about how to solve problems, how to address bottlenecks, and also how to do some troubleshooting. Another piece here is also the enabling automation. So for example, probably people heard about a path computation engine. Now, a path computation engine obviously needs to understand the performance of a transceiver of wavelengths over an optical network, but if that is kind of private and hidden and not exposed, there's nothing that you can calculate. Now, with the GNPY, that's the tool the PSE team is working on, you have at least a good idea of what the performance should be and whether you can reach the other end, yes or no. And that also gives you yet another advantage, because once you build your network, it stays there for 10 years, 20 years. And you often ask yourself, okay, if I get new demand on a route that has not been used much up to now, is my network still fit to accept that kind of extra traffic or not? And that also requires some planning. And that also requires some insight into what other reserves the network still have based on the actual usage. So all of those things kind of require a clear view of the performance and the plan the network really can fulfill. Not only what it fulfills right now, but also what it is able to fulfill in future. Next page, please. So what is the solution? Again, the key we identified is to have a co-design of a optical network with all stakeholders. Well, that means optical operators of optical networks talking to vendors of optical components, say transponders, talking to line system providers. So to be able to jointly understand what are the needs and what is the performance needed in order to fulfill a certain quality of service. Also, to jointly address challenging network design options that always there are. So there are different ways of addressing them. What is the best one? So this is something that needs to be openly discussed between operators and vendors. The consequence of that is we need a kind of an open planning tool for everybody. It really needs to be open so everybody can look at the same thing in the same format with the same values, so that there's no discussion about what does it mean to have a parameter 0.5 in here, so that it can be discussed among a lot of people. That again is enabling an optimal usage of system resources, because there's a shared view of where the system resources are, how much slack there is, and how much can be used in order to provide new services. And that allows also to validate a kind of a model accuracy with operators and vendors. So if you have an optical network, you can apply the planning tool and you see whether the planning tool accurately reflects what you see in the network. Next page. So what is the plan going forward? We are here in 2021. What we did was we did an experimental integration of GNPY into an open source controller, where GNPY acts as a path computation engine. So that is a kind of proof of concept. People can use it. GNPY is open source, so if you have your own controller, it's easy to integrate into your own controller as well. We also switched a little bit the internal tool set to Gerrit to facilitate the code development. We now have a lightweight graphical user interface, which you're invited to use on the location that is identified below. And we plan to have to publish the test results from a brownfield activity that we are running today in the TIP labs in Berlin, where we basically compare what is simulated to what can be measured. We also want to go forward to make it more operational, to run such kind of tests. So if you have your own network, if you're your own network provider and you want to do some testing to see where the bottlenecks are, you get a better documentation of that one. We also improve the integration into a path computation engine with a proper Yang model, so that it's easier for everybody to consume GNPY, and extend obviously the model to more modern ROADM architectures like FlexGrid and multiband capabilities, including the automation for lab testing and brownfield. So one of the thing of the open issues we are tackling right now is we need a better graphical user interface to drive the usability. We are there, we have a statement of work, and we are looking for collaborators that help us in developing this. Next one. So if you're interested to contribute and you're a network operator, vendor, system integrator, or from academia, you're invited to do so. We identified here a few actions where we could use some help. So network operators, it would be really great if you would use GNPY to plan your next network and see how it works for you. Feedback is more than welcome. Also, if you're a vendor or technology provider, try to expose your parameters let's say your performance using GNPY, do a simulation and see how it works for you. Because in the end, that is the basis for a discussion also with your customer. If you're a system integrator, you can kind of create a performance blueprint of your network before you roll it out. Again, GNPY is an accepted tool now in the industry. So by showing that you did this planning and what the results are, I think it incredibly increases also the usability of your planning. And finally, if you're in academia and you have a nice model or nice technology to extend the code base, for example, if you have an AI or a machine learning extension in mind, feel free to contribute. We're open. This is an open source code, and everybody is welcome to contribute, and we're happy to work with you. Thank you.
Great. I think now we are moving into the next section. So Victor, over to you.
So this is Victor from Telefónica, and today I'm here to talk with you about the mandatory use case requirement SDN transport initiative that we have started within the OPT working group. The reason why we have started this initiative is mainly because we consider that future networks will be disaggregated and programmability is a must. Operators have been struggling in the latest, I would say, 10 years to transform, optimize, and create an infrastructure that will be ready for the high capacity demands that we are receiving with all the evolutions, not just of mobile services, but also from our fixed customers. At the same time, there has been a massive work within academia and within the vendors and the industry to create solutions around software-defined networking that will help us to program the services that we were defining in our network. At the same time, as well, you know, here within the Telecom Infra project, we are working a lot on the disaggregation of the components in the software and in the hardware pieces. And if we want to have an open transport approach with these disaggregated components, it's going to be very important for us to have an SDN layer that will help us to operate, maintain, and configure our network devices. This is the reason why we create this initiative, this new working subgroup in OPT. MAST subgroup is coming with the objective to define which are the mandatory use cases for the network operators. The main agreement that we have achieved between 6 big operators like Vodafone, MTN, Orange, Telia, Deutsche Telecom, and Telefónica, we have agreed on a reference architecture for the SDN solution, also to follow a methodology based or focus in use cases, identify standard interfaces, not just open interfaces, but standard interfaces that will be part of a bigger fora that will help the industry and the suppliers to support these technologies. Also, we will follow a use case taxonomy in order to define which are the different aspects that we want to program in our network. And to found this group, we delivered this a white paper that you can find in the OPT website, where we explain in detail which are the different aspects of this MAST initiative. We plan to report periodically the use cases that we are defining, and this will be part of the work that we will do in MAST. Next slide, please. Which is the reference architecture that we have agreed with the different operators. You can see it here on this slide. So what we have seen is that we prefer to have a hierarchical architecture with a controller that will be in charge of the multi-layer requirement, the end-to-end use cases. But at the same time, we think that it was important to have an approach where there will be different multiple SDN controllers that are relevant and each of the transport segments that you will include within the scope of the OPT working group, that is IP, optical, and also the microwave and transport technology. So the idea that we have with this hierarchical architecture is to have a scenario that will be able to program, configure services all across the network, but at the same time we will be able to maintain the simplicity without having just a single SDN controller that will configure all the heterogeneous network devices. This approach is something that is not new and is totally aligned with the effort that it is done in other forums. So in the first fora that we check that are following this approach is ONF. Similarly, in ACTN, in the ITF, we have this approach, and also in the ITF, with the framework for service automation, they are following also this approach of having a hierarchical view. So in this sense, we believe that is aligned with the effort from different industries. We will work in RESTconf and NetConf interfaces with the standard YAM models in all the different interfaces. We will use RESTconf mainly to communicate with the SDN controllers, between the SDN controllers and with the OSS, BSS platforms. And we will use NetConf YAM in order to configure the devices that we deploy in the network. We will select for each of the interfaces the technologies that are more mature. So we will choose maybe ITF technologies for the IP domain, ONF technologies for the optics, or OpenConfig to configure the devices, or ONF models to configure the microwave devices. So the objective that we have is to find a solution that will be ready for the market and that will help us to achieve a faster deployment of SDN technology. That this is something that we haven't seen in the latest year, at least for network operators. Next slide, please. So why are we deploying SDN? We are deploying SDN mainly because we want to simplify our OSS integration. So today, when we want to configure a new device that we enter in our network, this requires long processes to integrate it with the OSS layer. Having a standard interface and a single common northbound interface for a given technology will help us to decouple the evolution of the network and the evolution of our systems. So this way we can select the best technologies for the network and the best solution for our OSS layer without impacting the evolution of one of the layers, or to minimize the impact between the evolution of one of the layers and the other. On the other hand, we have the network intelligence. We believe that activating SDN will provide us capabilities to enable, for instance, traffic engineering, automatic service provisioning. It will help us to facilitate the migrations and also our operational process. So nowadays, to retrieve the information take us some time, and we believe that having this SDN layer will facilitate this, thanks to this network intelligence, will facilitate this process. Open Transport, as I stated before, the idea with Open Transport and, for instance, project like DCSG is to provide new opportunities to new vendors to enter in our production environments. If we have the same interface toward the devices, it will facilitate the creation of free demand in our RFQs that any tender will be able to obtain. So this way, it will help us to have the best technology for each of the layers without requiring an integration with our OSS platforms. And finally, to make available network slicing as soon as possible. So all the control mechanisms that we require for soft slicing, mainly in the different devices, are very tight with programming these devices as soon as we retrieve different services requests. So 5-year slicing is something that we have in mind, and this is why SDN will help us also to deploy in our network. Next slide, please. How can we achieve SDN deployment? So our idea to have a pragmatic approach is to have a functional architecture that will be adapted to the real deployment that we will have in our network. Using industrial alliances and following mature standards will help our vendors in order to provide solutions that cope with the requirements that we are asking. So having this community of 6 operators, we believe it will speed up the process to deploy SDN in production. At the same time, network abstraction models will help us to minimize the time to market, because it won't require to program all the details of the network elements, and it will rely on the capabilities of the SDN controllers to abstract the complexity to our OSS. And finally, and I will talk a little bit more in the next slide, having a use case oriented approach, it will provide value little by little, and we will put effort on the definition, but just step by step, focusing on the use cases that are important for our operating business. Next slide, please. Which is the life cycle approach that we will follow for these use cases? So the idea is that we will start with the definition of the use cases. We will do this between the vendors, between the operators. We will start later with the modeling of the use cases based on the standard model that we have. We may need the support of our vendors in order to standardize new parameters or to include some functions that maybe were not part of the standard when it was defined. But as soon as we have this standard solution that we have for many use cases already, solutions out there, we will go to validate technically the use cases in mainly proof of concept, first in the lab and later in production. The idea is that we will activate these use cases and put them in production networks, and we will continue adding new use cases based on the needs and the feedback that we get from the different forums. As you can see, follow this life cycle approach is something that we can do by the operators ourselves. We need the support of our vendors and also the organizations that are coordinating all these industrial initiatives, like the one that we have in the Telecom Infra project, in order to make a reality all these SDN initiatives that we are launching within the Telecom, within OPT in the Telecom Infra project.
Great, thanks a lot, Victor. We are moving now into a disaggregated optical systems. Over to you, Johan.
Thank you, Diego. So my name is Johan. I was working for Telia company and co-chair of the disaggregated optical systems subgroup in OPT. So in the disaggregated optical system subgroup, we are focusing on defining and building open disaggregated optical devices and taking them to the market. So far, we have designed and defined 3 different devices, and they have been released. And in short, I will explain what they are. So Cassini is an open packet optical transponder, and the Galileo is an optical packet hardware platform by design. And now the latest product or project that we have named Phoenix is an open white box transponder that we can deploy on top of our existing line system to increase the capacity of our optical network. Both the Cassini and the Galileo products or devices are already now being taken into commercial use by operators around the globe, and we are currently working on taking the Phoenix transponder to our labs and for continued field testing. I think we can go to the next slide. And you can go one more. Thank you. As said, Phoenix is our latest product in the disaggregated optical system subgroup in OOPT. We, the operators, Vodafone, Telia, Telefonica, Deutsche Telekom, and NTT Communication, has come together, and we have designed a full disaggregated open white box optical transponder solution. The Phoenix transponder is designed by us and for us, and thereby fully based on our needs across our different networks. Can take next slide, please. Just to give some high-level examples of what was really important for us when we went into the design phase of the Phoenix product. The solution needed to comply to open APIs, relating back to what Victor just shared with us from the MUST initiative, meet our strict views on power efficiency and form factor, be fully modular and compatible with 3 third-party pluggables, but at least, and last but not least, it has to support high-speed interfaces like 400G and beyond. To achieve this, we believe that in this context, the most applicable way forward is to leverage the disaggregated model that we're developing within the Telecom Infra project. If we go to next slide, I can give you a wrap-up or a quick overview of the plan, what we have done and what we are planning to do going forward. So some of you know, or maybe most of you know already, we started the initiative in Q3 last year, and we managed to release our specification of the Phoenix transponder already in Q4. In the beginning of this year, hit by some slight delays due to the pandemic situation, but we managed to align our specification within the TIP community and with the hardware and software partners and members, and we launched an RFI just before the summer. And some of the key results of this joint RFI that we went out with to the market and to the partners in the community was a very broad proof of a broad support from the hardware and software partners on our disaggregated approach. So this made us feel quite good about what we are doing here. And we also saw that our functional and environmental specification of the transponders are very much on target with what we could expect from the vendors at this stage. Based on the responses on the RFI, we made a shortlist of several hardware, software, and integrators whom we are together taking the Phoenix solutions to our labs and fields for testing and verification. And our aim is to have general availability before summer next year. So that was a quick introduction and update on what we do in the disaggregated optical system subgroup.
Great, thanks a lot, Johan. So I'm going to close with a couple of final statements, and I promise I will be very quick. So the message that we want to pass to everyone that is listening and paying attention to this session is that together we will, right? By disaggregating optical and IP technologies, we think that we are accelerating innovation. And we think that this is a journey that we need to do all together, and a journey that we all need to push forward. By providing solutions that are more open, we'll accelerate innovation, we'll increase the supply chain diversity that operators can have and can use to implement better and more efficient networks. And last, let's go to the next slide and wrap up the session. As I said, we work on developing SDN solutions, IP routers, and we do integration. We work with system integrators. We develop technologies across the entire transport domain. And we encourage anyone that is working in these areas, operators, providers, system integrators, and any organization that is interested in building open technologies together with us to join us. And they are always welcome to join the Open Optical and Packet Transport Project Group. And having said that, I want to thank everyone for joining today. We are going to leave you with a quick video so you get to know more about what we do at TIP, what we do at the Open Optical and Packet Transport Project Group.
Our users will never really care about how their data packets run back and forth, as long as it happens quickly and reliably. That's why we are here. We are from the Open Optical and Packet Transport Project Group within the Telecom Infra project. And I'm Katja. Digitization puts ever greater demands on our networks. The overall load will increase exponentially to the point that we need to provide up to 800 gigabit per second or more on the channel of a line system. The increased traffic will also become less smooth and more dynamic, and it will shift from a predictable centralized to a much more unpredictable distributed pattern. So we need more capacity, but also more flexibility. And at the same time, we need to keep our costs under control. That's why we are looking for ways to increase efficiency and flexibility of our existing infrastructure to make our networks reliable, scalable, and ready for the future via disaggregation and testing.
Connectivity is a great opportunity. This industry is changing the way it used to do things. New business models are evolving, and open and disaggregated technologies are helping this industry by accelerating the innovation by open interfaces, increasing the robustness and flexibility of telecom supply chain by enabling supplier diversity, and hence improving the network economics.
The Open Optical and Packet Transport Project Group mission is to accelerate innovation in IP and optical networks and help operators providing better connectivity for communities around the world. We work with network operators and technology providers building solutions that are more open and more efficient. We start with an idea. We work with technology providers building prototypes based on that idea. Operators take those prototypes into lab and field trials, and eventually they become technologies that operators can take into their commercial networks.
TIP is working very hard to make these technologies a commercial reality by aggregating demand and achieving required scale. These disaggregated technologies required operators to integrate a diverse set of suppliers into an end-to-end solution. This integration needs a different level of skill set, and that is the purpose of TIP Integration Lab, to build that confidence in the operators.
So basically, we improve specifications and systems by collaboration with developers through creating reference configurations and joint tests. The joint use of the results by the partners within the project group ensures a step-by-step improvement and allows a reduction of cost for later integration. Vendors and developers are invited to provide their solutions and test them against the reference configuration in the course of Plugfests in our Open Integration Lab. By working together in this way, we offer a space for smaller companies to contribute to a much bigger end-to-end system.
Thank you everyone for joining today. Now I want to encourage you all to go through and visit our virtual booth so you can get to know more about some of the technologies that we develop and get to know more about open optical and packet transport.